It's recording. That's what that little ding was. It's recording.
You better watch what you say.
I'm going to be very cautious. That's what he just said. So thanks for repeating it. Okay, this lesson, it's about sequences. Um, this is a pretty fast unit. Basically, what we're going to do is today we're going to introduce sequences. Tomorrow we'll introduce series. Then we're going to talk about how to write equations for a specific type of sequences. They're called arithmetic. And then how to write them for another type of sequence called geometric. Those are going to be the formulas that we're really going to focus on knowing how to write. We're going to try to write a couple today, and they're going to be pretty challenging. Okay, I don't want to sugarcoat it. The formulas that we're going to write today, you have to think a little bit, and that is always a challenge. Always a challenge. Having to think, you know. So, anyways, but today we're going to just introduce this concept of sequences. And I know y'all know what sequences are because you've called them something else in the past that everybody in here has heard of, and that's called a pattern, okay? When we talk about a sequence, we're talking about a set of numbers that follow a specific order or a specific pattern, okay? So when we break down that sequence, each value in that sequence we call a term. There are two different types of sequences that we can talk about. We're going to deal mostly with the second one. Okay, you've got finite sequences, and y'all know the difference between the terms finite and infinite. Finite finishes, right? There's a stopping point, but infinite keeps on going. Same thing, okay? For finite sequences, it's a limited number of terms, where a finite or an infinite sequence is unlimited number of terms. And really the best way to determine is look at the end of the set. On that first example, it's just 2, 4, 6, 8 stops, right? So that's a very limited number. It's only talking about that specific sequence. But if you look at the second group, the second set, what does it do at the end? How do you know it keeps on going? The dot, dot, dot. Okay, dot, 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 saying, hey, it's going to keep on going. So finite versus infinite. Again, most of the sequences that we're going to talk about in here are infinite. They just keep on going. Okay, keep on going in math. Now, when it comes to terms, the very first term in a sequence is denoted as A sub 1. A sub 1. A sub 1. Okay, that's not a to the first power because that's not an exponent. Okay, it's down to the bottom right. So we say a sub 1. Okay? It's the difference between a subscript and a postscript. This is a subscript, a sub 1. Okay? If we're talking about any other term, we're just trying to define the terms in general, we're going to use this thing called a sub n, where n is the term number in that particular sequence, a sub n. When we write equations, we're going to use a sub n because we're going to use those equations to find specific terms. So a sub n is just, in general, defining a term within a given sequence. All right, so right off the bat, we have a sequence, and my mindset, or your mindset, I should say, going into this is numbers change in basically two specific ways. Numbers are either going up generally, or numbers are going down. Now we're going to look at a sequence here in just a little bit. It does something real weird. It goes back and forth, okay? Positive to negative, positive to negative, positive to negative. And when it does that, It doesn't really follow that order, okay? But in general, when I look at a sequence, I want to think, are those numbers going up? Well, if they're going up, what two mathematical operations do we usually focus on when numbers are going up?
Plus and multiply.
What was the first one?
Plus.
Adding, yeah, plus, adding, and multiplying. Those are generally the things we think of when numbers are going up, when they're increasing. What about when they're decreasing?
Division or subtraction.
Yeah, division or subtraction. Now, don't get me wrong, there's other things that you can do to numbers, right? Like exponents. You can use exponents, but still, technically, exponents is multiplication, isn't it? So, when numbers are going up, I start thinking adding or maybe multiplying. When numbers are going down, I usually think subtracting or dividing, okay? So, in this particular one, what are the numbers doing? They're going up, right? They're going up. So what I would recommend is just thinking through, what are the possible things that this thing could be doing to get from 1 to 5? Say that louder, Johnny. Going up 4 or adding 4, right? Adding 4. Well, let's see if that continues. What's 5 plus 4? What's 9 plus 4?
13.
Is that following that rule? Is it following that pattern? Okay, so my change in every problem is adding 4. Okay, so let's answer some questions. The first question is, well, what's a sub 1? What is my, let's say, what is my first term's value? Well, what is my first term's value?
1.
1, right? 1 is my first term's value. So what about a sub 4? What is my fourth term's value? 13, right? How about a sub 9? Do y'all have it up there? No, but to find a sub 9, I need what? To find a sub 9, to find my ninth term's value, I need to know what? I need to know my eighth term's value. Do I have my eighth term's value? No, so I need to know my seventh term's value. Do I know my seventh term's value? Okay, so we got to kind of go back. We got to work our way up to it. And what did you already say this sequence is following?
4s.
It's adding 4. So right now we got 1, 2, 3, 4. We got 5 terms, right? So what's my sixth term going to be? What's 17 plus 4? Okay, so that's my sixth term. How about my seventh term?
45.
How about my eighth term? And how about my ninth term?
33.
So boom, there's the one they wanted me to find, a sub 9. It's 33. 33. How about a sub 12? Well, again, so far we've gotten all up to the ninth term. So let's just make our way up to the 12th term. So if the ninth term is 33, what's the 10th term? What's the 11th term? And finally, what is my 12th term?
45.
45. Okay, this right here, and we're going to refer to this in a second. This is called recursion. Okay, this is called recursion. Recursion in math is where you need your previous term in order to determine the next term. You understand what I'm saying? And we're going to find that in a second. But for example, if I ask you guys to find a sub 100 for that sequence, would that annoy you? It should. Because to find a sub 100, what do you need? You need a sub 99. And to find a sub 99, you need to know what? A sub 98. You get the point? That would take a while, wouldn't it? Recursive formula is probably the most used concept in sequences, but it's not the best, okay? And we're going to talk about the best here in a bit. But anyways, let's define a couple of things. You can also consider sequences as functions. I want to take you guys back to when we did functions. Functions always had two values. It had a value that we called the input and a value that we called the output. Now, in those functions that we dealt with, most of the time, the input was defined as x, wasn't it? And you would plug x in, and you'd work that little problem out, and it would give you the answer for what? What was the other variable? F of x, or we also called it y. So we would input an x value, and it would output a y value. So it had two values. So a lot of times people look up here at a sequence like this one right here, and they're like, there's no way that's two values. It's just 1, 5, 9, 13, 14, 17, 21, 25. That's one value. How do I define that as a function? Here's how. We called one, what term? It was the first term, right? So the first term was what? 1. What was the second term? 5. What was the third term? 9. What was the fourth term? 13. What was the fifth term? 17. Get the point? When we have a sequence, we do have a comparison of two values. The term number and the term value. You understand? So sequences can absolutely be thought of as functions, because we not only have term number, we also have term value. And that's how we define these. So your input, your x, your domain, your n, is going to be the set of your term numbers. And the range is always going to be the set of your term values. And I hope that you can remember the example here that I explained. 1 is the term value for what term? The first term. So your term number is 1, your term value is 1. Second term is 5. So your term number is 2, your term value is 5. You follow? And that's what's defined here in these boxes as well. Same pattern, same sequence, okay? Last thing before we move on to recursive formulas is, in an infinite set, the domain, the n values, the input, is a set of all what we call natural numbers. Natural numbers. Just curious, does anybody know like the definition of a natural number? You guys actually did this in the past. Nobody's known it up to this point, third period. Y'all remember when you defined like whole numbers and real numbers and irrational numbers and natural numbers? Y'all remember when y'all defined these? Integers, did I say integers? Natural numbers are easily defined as counting numbers. Counting numbers. Let me explain. If I start counting in here, and I start over here at Reuben, when I go 0, 1, 2, 3, would I go like that? Would I start at 0, counting? No, I'd start at 1. Would I go 1, 2.3, 3.7? Would I do that? No. If I'm counting, what do I say? 3, 4, 5, 6. Natural numbers are counting numbers. So the point is, when we deal with the domain of any sequence, your domain is going to be your counting numbers. You're never going to have a 0. You never have a 0th term. Okay? That's not even definable. Your first term is. Your second term is. There's no such thing as your 3.4 term. Okay? Your domain only includes counting numbers, natural numbers. 1, 2, 3, 4, 5. Your first term, your second term, your third term. You understand what I'm saying? Y'all with me on that? Okay. There's no such thing as your 0 term. Okay? When we're dealing with sequences. Alright, so let's move along. I want you to write these down. Oops, I didn't mean to write this yet. I'm going to erase this. Write everything else though. Didn't mean to leave that on there. Y'all write the definition and then we'll talk about it. And also write that a sub n minus 1 over there by the recursive formulas. It's important. real is important. Jason, you have a birthday, huh?
Yeah.
Today? Anybody give you your birthday beat down yet?
Oh, no.
You may bring these red sticks back there and do it?
No. Wouldn't be good.
For me or you?
We are recording this, by the way.
But you gotta get a birthday beat down.
Oh, yeah, we are recording. Yeah.
Oh.
Might stop to, see.
Maybe you have
Oh
some birthday.
my.
Yeah, $9 will walk away.
You gotta get a birthday beat down at some point today.
I'm gonna send that to the principal and see how he thinks about that.
Oh,
You
I'll
give
beat
it-
him up.
Okay.
I don't even care. Easy. Yeah, he's soft.
Oh, yeah.
Oh.
Yeah,
Has to be.
I can
Wow.
take it.
Oh, of course. When was it this time?
I think there's only one administrator I couldn't beat up.
Who?
Mr. Skipper. He might be a little bit of a challenge. I can take him. Mr. Knox, easy. Mr. Creek, easy. Either of the girls, I could take them easy.
I'd like to see.
I don't know, Miss Wright might give up a little fight.
Yeah. No. Yeah, she would. She's a little soft.
I can beat her up though.
Okay.
I can take everybody but Mr. Skipper.
You like that kid in second grade? He's like, beat back.
No, I can't beat up Mr. Skipper. Have you seen him?
No.
He's pretty stout.
He built. Oh, yes,
He's just
yes,
strong.
he's built.
Alright, y'all got this written? So here's the deal with what we call recursive formulas. Recursive formulas have to call on the previous term in order to find the next term. Look what it says. A rule in which one or more previous terms are used to generate the next term. For example, go back to that sequence above. That was a recursive formula. How do we find a sub 12? Y'all remember? How do we find a sub 12?
You add.
We kept adding 4 until we had a sub 11. And then I could simply add 4 to it, and I found a sub 12. See, recursion says, I need to know the previous term to find this new term. There's another method that we're going to use in just a minute. It's called explicit formulas. Explicit formulas are different. You don't have to call on the previous term, okay? If I want to find the third term, I get to plug in 3. We'll talk about that one in just a second. But the recursive formula says, if I want to find the next term, I need to call on the previous term, or the previous terms, as we're going to talk about with this thing called the Fibonacci sequence. So when you see this a sub n minus 1, that's the key. Okay, that's the thing that you really got to focus on, because when you see that a sub n minus 1, a sub n minus 1 is calling on the previous term's value. Let me explain. If I wanted to find the 5th term, for example, so if I wanted to find a sub 5, I would have to plug in here 5 minus 1, which is what? 4. So if I want to find the 5th term, I've got to use a sub 4's value. You see what I'm saying? What if I want to find the 18th term? Well, what's 18 minus 1?
17.
So to find the 18th term, I've got to find a sub 17 first. So a sub n minus 1 is what you're going to see that calls on the previous term's value. And we're going to talk about that in just a second. But let me remind you guys of this thing called the Fibonacci sequence. Have you ever seen this before? This follows a recursive formula. Okay? Here's the recursive formula it follows. You ready? To find a term, y'all writing this? To find a term, to find a sub n, you got to take a sub n minus 2 and add a sub n minus 1. So what in the world does that mean? All right, well, what terms have they given us so far? They've given me my first term's value. They've given me my second term's value, 1. They've given me 0 and 1. You follow? So we want to find which term now? We want to find the third term, right? We know 1 and 2's term. Let's find the third term. Well, look, if I want a third term, look what I got to do. What is 3 minus 2?
1.
So this says a sub 1 plus, what's 3 minus 1? 2. So this says a sub 2. So to find a sub 3, we got to take a sub 1 and add it to a sub 2. Well, what was a sub 1 and a sub 2? 0 and 1. 0 and 1 were a sub 1 and a sub 2. So what is 0 plus 1? So to find the third term, I had to add the first two terms. Now look, I'm going to do this one more time, and then we'll just go faster. Let's say we want to now find the fourth term. Well, again, what's 4 minus 2? A sub 2. What's 4 minus 1? A sub 3. So if I want to find the fourth term, I got to do a sub 2 plus a sub 3. Well, what is a sub 2's value? What is a sub 3's value? What's 1 plus 1? So the Fibonacci sequence calls on the previous two terms to find the next term. So what two terms do we got to use to find the next term? What are the previous two? Nope, what are the previous two? 1 and 2. What does 1 plus 2 equal? 3 is the next term. To find the next term, what are my previous two terms?
2 and 3.
What's 2 plus 3? 5. To find my next term, what are my previous two terms? 3 plus 5?
8.
To find my next term, I got to call on my two previous ones. What are my two previous ones? 5 and 8. What's 5 plus 8? What's my next value? 21. Next one? Nuh-uh. 34. And then we're going to go dot, dot, dot. Infinite sequence, right? Infinite. That is how you do a recursive formula. And that is not a hard one. It just calls on your previous two terms. We're generally going to just call on the previous term for the ones that we're going to write. But anyhow, that is called recursive. Recursive formulas call on your previous term or previous terms values. So, for example, let's go down here to number 1. What do the instructions tell me to do? Find the first 5 terms. Well, I want you to notice, right off the bat, what does it tell me? It tells me a sub 1 equals what? Isn't a sub 1 indicating the first term? So what is my first term's value? 14. We need to find the first what?
5 terms.
The first 5 terms. So we got to figure out, how do I find the next term in this recursive formula? And how do I know it's recursive? Well, look, do you see a sub n minus 1 in it? So what is it saying it's doing with the previous term? This represents your previous term. What are you doing with your previous term? Adding 9. So if I want to find my second term, I'm going to take my first term and I'm going to add 9. What's 14 plus 9? 23. If I want to find my third term, what do I do? To what? My previous term, 23 now. What's 23 plus 9? 32. How do I find the fourth term? To what? The previous term is? No, the previous term is 32. 32 plus 9? 41. And then the last one, because it said to find the first 5. 41 plus 9? 50. You see, you weren't able to go straight from the first term to the fifth term. You needed to go one at a time. First term it gave you 14, and then you knew you had to take that previous term and add 9 to find the next one. So 14 plus 9, 23. 23 plus 9, 32. Yes, sir?
So where does the minus 1 come?
It's just how you call on your previous term. Remember, if I'm trying to find a sub 4, I've got to use a sub 3. So that's where that n minus 1 comes from. It's taking 4 minus 1 and saying a sub 3. So if I want to find a sub 4, I got to take a sub 3 and add 9. If I want to find a sub 10, I'm gonna take a sub 10 minus 1, a sub 9, and I'm gonna add 9. So it's calling on the previous term. When you see that a sub n minus 1, it's calling on the previous term. Okay? A sub n minus 1, calling on your previous term. Y'all gotta get that in your brain, okay? Alright, so let's look at one more example of this. Go on down here to, right here. No. Yeah. We'll do this one, number 4. Number 4. This time, it gave you how many terms? It gave you a sub 1, which is 3. And it also gave you a sub 2, which is 4. So we only have to find how many? 3. So what does it want me to do? Well, to find a sub n, I got to take a sub n minus 1. That's the previous term. And I got to multiply it by a sub n minus 2. That's the previous term's previous term. You follow? So if I want to find a sub 3, I need a sub 1 and 2. What was a sub 1? What's a sub 2? What's 3 times 4? So this is a lot like the what? This is kind of similar to the Fibonacci, except we're not adding, we're what? Multiplying the previous 2 terms. So for the 4th term, we need 2nd and 3rd, right? So what's 4 times 12?
32.
No. 48. You got to multiply. And then y'all might need to help me on this one. To find the 5th term, 12 times 48?
576.
What is it?
507.
You do that in your head?
No,
Oh, okay.
I wrote it out.
Yeah, I could have done it in my head. Do you want me to tell you how I would have done it in my head?
No.
What's 12 times 100?
1,000?
Yep, 1200. Divide that by 2. And then subtract 24.
But why would you even think of that?
Okay, here's how I do it. Since 48 is so close to 50, which is half of 100, so I go 12 times 100 and then divide it by 2. That gets me to 50. But I'm 2 shy of 50, so I have to subtract 2 12s. So I subtract 24. So in my brain, I go 12 times 100, 1200, divide by 2, 600 minus 24, 576.
Wow.
But I do it pretty fast. I'm just saying, that's how I do that mentally, where I don't have to type it into the old calculator.
Wait, are you saying you're faster than I thought?
No, I'm not faster. That's why I told you guys to use your calculator to help me out.
Oh,
I'm not faster than calculator there. I'm not too far behind it, but yeah, not faster than calculator. So anyways, if we did the next one, 48 times 576, I'd be screwed. There's not a good trick for that one. So, I mean, it'd be a lot harder. So anyways, there's that one. Now I want to come back to number 5 in a second. I want to go first to explicit rules. So let's skip 5. We're going to come back to 5 in a minute, and I want you guys to write these notes right here for explicit rules. Explicit formulas. These are my favorites. The reason these are my favorites is because, remember that question I asked you earlier about if I want you to find your 100th term, how annoying that would be? Because if you had to find the 100th term, you had to find the 99th, and then the 98th, and the 90th. Remember, you had to build to it. With explicit rules, there's no building. If I want to find a 100th term, I can find the 100th term right now. Okay, if I want to find the 673rd term, I can find the 673rd term right now. Okay, that's what the explicit rule does. Explicit rule is a rule in which the nth term is defined as a function of n. Blah, 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 right? Here's what that means. If I want to find the 5th term, guess what I get to do? Plug in 5. I can plug 5 right into the equation, and it will find my 5th term's value. If I want to find the 100th term, guess what I plug in? 100. Because if I plug in 100 into that explicit rule, it gives me the 100th term's value. One more time, and hopefully you guys will answer this one. If I want to find the 650th term, what do? You plug what in? You plug 650 in. That's the difference. In recursive formulas, I need to know my previous term to find my new term, right? So it builds, it builds, it builds. But in explicit rules, if I want to find my 8th term, I plug in 8. If I want to find my 15th term, I plug in 15. It's way simpler, even though a lot of times what we end up doing is we end up going back to recursion. Let me prove that. Look at number 7. The instructions are the same. It wants me to find the first 5 values. Do they tell me my first value? No, it's not recursion. Recursion, they have to tell you your first term. But here they don't. If I want to find my first term, what do? I plug in 1. What is 1 minus 3? What's negative 2 times 7? So my first term's value is negative 14. How do I find my second term? Plug in 2. What's 2 minus 3? Negative 1 times 7. Negative 7. See, I didn't base it on negative 14. If I wanted to find my second term, I just plugged in 2. What do I do if I want to find the third term? Y'all not catching yet?
3.
I plug in 3. What's 3 minus 3? What's 0 times 7? If I want to find my fourth term, what do? Plug in 4. 4 minus 3? No, 4 minus 3 is 1. 1 times 7? 7. You're right. And if I want to find 5, 5 minus 3? 2 times 7? Now here's the point. At some point when we were doing this, the majority of you guys, your brain saw that you're doing what every time?
Multiplying by 7.
Adding
Adding
7.
7.
Every time. Y'all started, how many of you guys at some point recognized that was the pattern? You're adding 7 every time. And all of a sudden, you turned it back into recursive. You stopped doing the explicit, you turned it back into recursive. Instead of plugging in 4, you probably said, hey, it's adding 7 every time. 0 plus 7, 7. It's adding 7 every time. 7 plus 7, 14. You turned it back into recursive. You understand what I'm saying? That's why I would say recursive is the easiest form of sequences, because you see the pattern and you apply the pattern to the previous thing. That's recursion. Explicit says, though, if I want to find the 4th term, I can plug 4 in. If I want to find the 8th term, I can plug 8 in. I don't have to have the previous term to find that term. Do you understand? Okay, so that's the big difference between these two types. Recursive versus explicit. So let's do one more. Look at 11. This is the one I referred to earlier. If I want to find the first term, I plug in what? 1. What's 1 minus 1? 0. So what's negative 2 to the 0 power? You might need your calculator.
1.
It's 1. Remember, anything to the 0 power is 1. If I want to find my second term, I plug in 2. What's 2 minus 1? 1. What's negative 2 to the first power? Negative 2. And this is where it turns really interesting. Third term, plug in 3. What's 3 minus 2? 3 minus 1. I said the answer already. What is negative 2 squared?
4.
Positive 4. So all of a sudden, what do you notice this thing's doing? It's going back and forth from positive to negative to positive. You think the next one's going to be negative? Let's see. Let's find the 4th term. What's 4 minus 1? 3. What's negative 2 to the 3rd power? Negative 8. And to find the 5th term, 5 minus 1 is 4. What's negative 2 in parentheses raised to the 4th power? Positive 16. So again, it's going back and forth, back and forth. Every time it's multiplied by negative 2. Look, 1 times negative 2, negative 2 times negative 2, 4 times negative 2. You see that? This is a geometric sequence. And we're going to talk about that, I think, on Tuesday of next week. All right? Now, let's go back to number 5, if you will, with me, please. You have to kind of wrap your head around this, and it's kind of tricky, okay? The difference between recursive rules and explicit rules. You see, recursive says, I gotta know my previous term. So for example, what is my first term here? So I'm gonna define that. I know that my first term is 4. Recursion says to define a sub n, I gotta do something with my previous term. I gotta do something with a sub n minus 1. So I've got to figure out, how do I get from 4 to 11? So some people might think, well, I add 7, right? Add 7. Well, what's 11 plus 7? Not 32. Not 32. So I'm not just adding 7. But the numbers are increasing, so I start thinking multiplication. Okay? Go with me. What's the smallest thing you can multiply 4 by? 2, right? What's 4 times 2?
8.
What's 8 have to add to get to 11? 3. So let's try to multiply by 2, add 3. Ready? Multiply by 2, add 3. What's 11 times 2?
22.
What's 22 plus 3?
30.
That's not it. 25, right? So I start thinking, what's the next thing I can multiply 4 by? 3. What's 4 times 3?
12.
What do I do from to get from 12 to 11?
Minus 1.
So let's try to multiply by 3, subtract 1. Multiply by 3, subtract 1. What's 11 times 3? 33 minus 1? Boom. There it is. Try it one more time. 32 times 3? 96 minus 1? 95. There it is. My recursive rule for this is, I'm taking the previous term, I'm multiplying it by 3, and I'm subtracting 1. I'm taking a sub n minus 1, right? That's my previous term. I'm multiplying it by 3, and I'm subtracting 1. So there's my recursive formula. You've got to define your first term. A sub 1 is 4. Then you got to state, to find my next term, I've got to take my previous term, multiply by 3, and subtract 1. Now, that's pretty tricky, isn't it? I don't want to sugarcoat this and say, oh, this is easy. Writing recursive and explicit formulas are challenging. Okay? It can be. The type that I care about us writing, the arithmetic and geometric sequences, we're going to talk about those on Monday. But I want you to go down here, all the way down to number 16, for me to show you the concept of explicit rules. Explicit rules, you don't have to know the first term. We can go straight into writing this equation, and what we have to think about is, what's it doing to your term number? Remember, to find a sub 1, we plug in 1. To find a sub 2, we plug in 2. So we've got to think differently on this type of explicit formulas than we did with recursive. Recursive, we were like, what did we do to 4 to get it to 11? Here we're saying, what do we do to 1 to make it 1? What do we do to 2 to make it square root of 2? What do we do to 3 to make it square root of 3? What do we do to 4 to make it positive 2? What do we do with 5 to make it square root of 5? You may have an idea.
Square root.
You're taking the square root of n. The square root of n is your explicit rule. How do I know that? Because the first term you plug in 1. What is the square root of 1?
1.
Perfect. For the second term, you plug in 2. What's the square root of 2? Square root of 2. To find the third term, you plug in 3, square root of 3. To find the fourth term, you put 4, square root of 4 is 2. So on and so forth. So my explicit rule is all based on n. My recursive rule is all based on my previous term, a sub n minus 1. You understand the difference? Kind of tricky, but if you can get that through y'all's thick skulls, just tell me, it's a challenge though, okay? I don't want to say, well, hey, writing these explicit rules and writing these recursive rules is easy. It's not always easy. They're kind of challenging. So you're going to have 3 tonight where you have to try to write these. So let me get these papers out to you, and then I'll explain the homework. It's a little tricky, so stay with me. Don't check out on me yet. I got it. It won't even take long. So here's your homework. Y'all ready?
Yeah.
On the front of that worksheet, you need to do 2 through 14 even. 2 through 14 even. But here's where it gets tricky. I want you to omit 6, add 5. Omit 6, cut out 6, and do number 5 instead. So 2 through 14 even, but no 6. I want you to replace it with number 5. Number 6's equation was too hard. I didn't even want you to think about that one. It was too challenging. So that's your homework. 2 through 14, but I want you to omit number 6 and add number 5. Okay?